Project P9 Track USV, by Kaushik Raju and Sheelabhadra Day. The objective of the project was to design a behavior for the UAV to continuously track Emily. Additionally, we needed to minimize camera movements to ensure that Emily stays in view all the time and not necessarily in the center. The approach we follow is a simple one. We have a rectangular bounding box. If Emily is inside this bounding box, we do not send any commands. Now, for instance, if Emily were to go into region R2, we would send a negative angle in the X direction to bring Emily back to the X center. The X and Y centers operate independently. For our experiments, we set the bounding box at 20% of image frame. We essentially send curl commands over to the server, which brings the required change. Photokite, however, accepts this change in radians per second. We first calculate the angle by which the camera needs to be rotated. Then we send this angle divided by 3 to Photokite. This is done to comply with the maximum rotation speed. Finally, after 3 seconds, we send a 0 value to stop the rotation. For testing our algorithm, we ran both the continuous and the 20% configuration through the same set of experiments in the lab. We set a specified path and using the dummy, we followed the path at the same speed. We first present the video of the continuous testing. As can be seen from the video, the algorithm is continuously making small adjustments to try to bring Emily to the center. Even when Emily is almost at the center, it still makes curl commands and makes the system clog the server with several commands. This also makes for a very shaky video. Now, for the video when the bounding box is set to 20%. As we can see, the camera makes adjustments only when Emily nears the boundary. When Emily is inside the bounding box, it does nothing. This makes for a more stable video for supervision and is really helpful when Emily is farther from the camera. When Emily is farther away, it will take a huge time for it to go out of view and the algorithm appropriately makes very few movements to keep Emily in view. Here are our final testing results. Not only did our algorithm let Emily go out of view fewer times, it also made only a fraction of the adjustments. Only about 1/10. Since the continuous algorithm keeps moving the camera, the unstable video makes Emily go out of view more times. A highly stable video of our algorithm ensures that Emily stays in view longer.